Hello, my name is Jonathan Apostle, and this is my fourth lab for Physics 2212. For the introduction, the purpose was to see how different circuits, either with direct current or with resistors, demonstrates energy conservation. This relies on Kirchhoff's loop rule, which is a fundamental principle. We utilize capacitors to demonstrate this change. The different things we accomplished was first, measure the resistance of the resistors in the series. This is mainly for confirmation. Measure current across different points in the series, and finally find the RC constant in the series. The results were we found a RC constant of 7, and overall we saw a clear trend in voltage drop in the series circuit. So now for some main physics ideas. First, the node rule. So within the system there is a charge conservation. In other words, the current must be the same flowing into and out of a node. Also Kirchhoff's loop rule, which was talked about earlier. The sum of the potentials in energy will be 0 for the circuit, so this is assuming that it is closed. This is similar to the node rule in that there is a conservation of energy, and also Ohm's law, which is a way to find current and make it proportional to voltage, and the formula is listed here. All right, so before I discuss the methods in a little bit more detail, I wanted to look at the system and the surroundings, and then also the initial conditions. So for the system, the circuit is a system, and depending on the circuit, this will include the battery, wires, bulb, or the capacitor. And then the surroundings is literally everything else. This includes the table, earth, hands, and voltmeter. Some additional materials needed and the initial conditions. So there's going to be two 1.5 volt batteries, a 47 ohm and 100 ohm resistor, and then also the 200 millifarad capacitor. This was also given to us. I didn't need to calculate this value. And then we also needed to make sure the materials were correct and properly labeled. This primarily goes for these two resistors. I just measured those, which is a part of my methods. And then an additional note, there was a combination of written calculated portions, but I paired these with physical circuits in the lab. And again, this is altered from the initial rubric because it just says you have to do it all online, but we obviously didn't do that. So before I get into the RC constant portion, I want to talk about what's going to happen when we put the ammeters here and what the current value is going to be. So after I did some calculations based off Ohm's law, I found a value of the current being 0.02 amps. And again, I confirmed this with the voltmeter. Methods, there's three major steps. First, find the current at different points on the circuit. Next, find the times that it took for the capacitor to charge and discharge. And then with this, we can find the RC constant, again, 30 ohm resistance. Now, one of the key portions of this lab was to calculate the voltage in the series circuit, more specifically, the change or the drop in voltage. So I found this given that the current is going to be constant, therefore there's going to be a clear drop in voltage across each of them. So I calculated these values, and again, I confirmed this with my voltmeter. Here's the chart that shows how the voltage drops. Now, looking back at the RC circuit, when I did the 10 ohms, I found 15 seconds, 20 ohms, 30 seconds, and then 30 ohms with the capacitor. This took about 19.3 seconds. To find the RC constant, we use the same principles as Ohm's law. We take the resistance of the bulb and then multiply it by the current. This is going to give us an RC constant of 6. So graphing that 47 ohm, I found the natural logarithm of the voltage divided by the initial voltage, found the slope, and then the inverse of this is going to be equal to the RC constant as specified in the instructions. As you can see, there's some slight error here. All right, now talking about some sources of error. So the most likely one is just human error. It required me, the lab that is, to measure the values by hand and record them. Also, my hands were not super steady, and this most likely messed with the readings on the voltmeter. And then lastly, I did have some issues charging and discharging the capacitor, so that might influence the times. Now, looking at the conclusions and the similarities and differences, the trends overall were correct, especially for the RC constant, the drop in voltage, and the resistance, but the values were a little bit off. There's a few reasons for this, and this is most likely due to human error. So for the series circuits, the values we found in terms of the charge in voltage made logical sense because it drops over time, and were simultaneously confirmed with my own calculations. For the RC factor, I was able to determine that the EMF of a capacitor changes over time, which makes logical sense because the voltage is going to kind of escape. And there were also significant errors. Again, these are most likely due to human error, not the actual setup or the materials. Also, it was kind of confusing for me to know what aspects of the lab were necessary to do, or what we need to do for pure calculations, which is why I combined some of the calculations, but then confirmed it with the actual voltmeter. Now to answer the what if and what does it mean questions. First, how would it differ for a real versus an ideal ammeter? So there will be a difference because for an ideal ammeter it would have zero resistance. However, this isn't true. So real ones do not have zero resistance. There is a slight amount of internal resistance, and thus this makes it more likely to increase the current because of Ohm's law. a real battery to charge the capacitor versus a virtual one. And this was really interesting. I had to do some research in the textbook for this. But a capacitor connected directly to the battery would charge literally immediately, since there is not any resistance in the current. In other words, the time is due to the internal resistance of the wires, but also mainly the capacitor. Here's a summary of what I did. Please use this if you have any questions about the rubric.